right, if you're going upstream, you guys, is the water helping your boat or working against your boat? Yeah, if you're going upstream, right, the water is working against the boat, okay? So when we do rate, right, distance equals rate times time. So this represents the rate with the water working against us because we're going upstream. So the water is not helping our boat, okay? And over here we've got downstream. If we're going downstream, that's with the water, so the boat and the water's rate are added together. So we're going to go a lot faster if we're going downstream, right? Okay. And then we have our times. We have upriver, time, downriver, and then our distance downriver, distance upriver. Okay. All right. So Edward and Lorena go 50 miles downstream. Look, your little pictures here. Oh, you guys are so cute. All right. In the same time, you can't really see them. Maybe we need to make these a little bigger. Oh, there you guys are. Nope. Nope. Too hard. Oh, there we go. There you go. You guys have a nice boat. All right. Edward and Lorena go 50 miles downstream. In the same time, it took them to go 30 miles upstream. So they went down the river and they went up the river. All right. If the speed of the boat was 4 miles per hour in still water, what was the speed of the current and what were their times? All right. So let's get some colors going here. So we got 50 miles downstream. So if we're going downstream, is that the boat with the water or the boat against the water? With water. Helping us out. We're going downstream. Times the time going downstream equals 50. All right, so we got 50 miles total going downstream. All right, and then we went 30 miles upstream. So the boat minus the water, because we're going upstream, right? So times the time upstream equals 30. So we only went 50 miles down the river, and we went 30 miles back up the river. By we, I mean Lorena and Edward. It was a fun trip, all right? If the speed of their boat was 4 miles per hour in still water, so speed of the boat. So where am I going to put this 4 in? What variable? Yeah, in both equations, okay? So I'm going to go ahead and rewrite this. 4 plus the water, PD equals 50. And the 4 minus the water, time up, equals 30. So speed of my boat was 4 miles per hour. All right, into the water. What was the speed of the current, and what were their times? So now we have to distribute our times. So I'm going to multiply my TD. So I have 4 TD plus W TD equals 50. And distribute here. Oh, one thing I forgot to do. It was the same time, right? So if it was the same time, TU is equal to TD. So is everybody good with just saying that means time equals time? The same time, right? So basically I can get rid of my subscripts if we have equal times. Time up and time down are the same. That does help us right here. So this one becomes a really easy elimination problem now that we've got positive WT and negative WT. So these are going to cancel right here. And I'm going to add these together. That's 8T equals 80. So time is 10 hours. And this is the time up and the time down because it said same times. That was a 10-hour boat trip, you guys. All right. That's quite a trip, all right? So now, what was the speed of the current? So we got to plug that in. You can plug in this time wherever you want. I'm going to go up to this equation right here, and it plugs in for both T's, since they're the same here. So 40 plus 10W equals 50. Subtract 40 from both sides. So 10W equals 10. So divide by sides, both sides, yep. So anyways, W equals 1. What does W even stand for? It stands for the speed of the water, or the current. So this would be miles per hour. All right, so the water is moving at 1 mile per hour. And that's all we had to find for the first one. Come back. Okay, good. The sloop Zolly, that's a boat, could go 33 miles downstream in 3 hours, but required 4 hours to go 12 miles upstream. That makes sense, right? It takes less time. What was the speed of the boat in still water, and what was the speed of the current? All right, so we've got downstream is 33 miles in 3 hours. So is downstream with the water or against the water? Right, so the boat plus the water. So the boat plus the water. We're going downstream. And it gives us the time this time in 3 hours. So I'm going to go ahead and put that, and that equals 33. All right, now the next one it says it required 4 hours to go 12 miles upstream. So is upstream with the water or against the water? Against the water, so it's not helping us move any faster. So boat minus water, and this time it took us 4 hours, and we went 12 miles upstream. Okay, so I'm going to go ahead and distribute the 3 and distribute the 4 here. So this goes to both. I have 3B plus 3W equals 33. And over here, the 4 distributes 4B minus 4W equals 12. Now, there's a way to make these problems a lot easier. If you can do this, I recommend it, all right? You could just do elimination how it is, right? Multiply by 4 and 3. But I think it's easier to actually divide the 3 out right here, right? Since that whole thing's divisible by 3, now I have the boat plus the water equals 11. Right? And the second equation, what are they all divisible by? Right, so I can actually divide every single thing by 4. So boat minus water equals 3. This just saves some time, all right? It's less work if you can divide something out like that. Now notice my W's just cancel when we add down right here. So I have 1B plus 1B equals 2B. Make sure you add those. Those cancel, and over here we get 14. So B equals 7. B stands for the speed of the boat. So this would be miles per hour. Okay. And what else did we have to find? The speed of the water. So if I go back to either one of these equations right here, the boat is 7 plus the water has to be 11. So the water has to be 4 miles per hour. That's it for that one. All right. One more. The water in Flint River flows at 5 kilometers per hour. So a speedboat can go 15 kilometers upstream in the same time it takes to go 25 kilometers downstream. How fast can the boat go in still water? So basically, how fast is the boat, right? So still water, that's just the speed of the boat. All right, so we've got 5 kilometers per hour is the speed of the water for both equations. We've got same times, so times are just going to be T for both. And we've got a speedboat going 15 kilometers. All right, upstream. So is upstream against the water or with the water? Against the water. So the boat minus the water. And we actually know the water, right? So I'm going to go ahead and plug that in. So the boat minus the speed of the water, which is 5, times the time, equals 15. Now we're going to go 25 kilometers downstream, which means with the water, so we're going to add them together. The water stays 5, right? It's 5 either way. And this time we went 25 kilometers. So you have to distribute on this one. Let's go ahead and distribute that t. So bt minus 5t equals 15. And over here, bt plus 5t equals 25. This should look really familiar to you guys, right? We just did a bunch of these. It was on the last test. I think almost everybody got this problem right. So we add down, right? We have a double variable. We get 2bt. Those cancel. Equals 40. So bt equals 20. You're not done here, right? Make sure you solve for each individual variable. So we have to go back up. I'll probably just go to this top equation right here, and I'm going to substitute in bt is 20. So 20 minus 5t has to equal 15. So subtract 20 from both sides. That would be negative 5. So the time is 1 hour. And don't forget, you have to use this equation here to find the speed of the boat. So plug the 1 in for time. And the speed of the boat is 20 miles per hour. Any questions, you guys?